Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to discuss about mirror formula. In our previous class we have discussed about it. We know the formula, but today we are going to derive mirror formula. So the mirror formula is the mirror formula is one by F is equal to 1 by U plus 1 by V, where F is equal to focal length, U is equal to object distance from the pole, and V is equal to the image distance from the pole. Derivation of mirror formula for a concave mirror of small aperture when the image formed is real. Now friends, let us draw a concave mirror. This is the principal axis. This is pole. This is focus. And this is center of curvature. Let us assume an object AB is placed beyond the center of curvature. Two rays are coming out of the object. So let us assume from this point, from the tip of the object, two rays are coming out. The first ray goes parallel to the principal axis, and after striking the mirror, passes through the focus. Let us name this point D. Another ray, let us take another ray which strikes the pole, and after striking the pole, it passes like this. So this is our second ray. Let us assume another ray. Let us take another ray which passes through this point. So let us take another ray passing through the center of curvature. So this is the point of intersection where we can get the image. The image is A dashed B dashed. Okay, this is our image. Now let us see the focal length. So this is our focal length, which is minus f, because we are measuring it opposite to the direction of light. Now the object distance, this distance is the object distance, which is also negative, and image distance. Okay, this is our image distance, which is minus v. Radius of curvature, radius of curvature, which is this distance cp. This is our radius of curvature cp. So this distance is minus 2f. Okay, minus r is equal to minus 2f. This is our radius of curvature. So I hope this is clear to you. Now in triangle ABC and triangle A dashed B dashed C, that means this small triangle, this is our bigger triangle ABC and this is the smaller triangle. Okay, in these two triangles we can say these two triangles are similar. Why? Because this is, see very carefully, we can write angle ABC and is equal to angle A dashed B dashed C equal to 90 degree, and this angle is equal to this angle because they are vertically opposite angles. Angle ACB is equal to angle A dashed CB dashed, because they are vertically opposite angles. So when two angles are equal, we can say the third angle will also be equal. When two different triangles have three sets of equal angles, then we can say these triangles are similar. And therefore, we can say angle ABC is similar to triangle A dashed B dashed C. Okay. So when two triangles are similar, their when two triangles are similar, the ratio of corresponding sides will also be equal. So we can write AB by A dashed B dashed is equal to, okay, this side is corresponding to this side, and BC by B dashed C. Okay, this is what we can say. Now BC can be written as, it can be, BC can be written as, this distance can be written as BP minus CP. See carefully. BC, this distance can be written as BP minus CP. So we can write BP minus CP, and B dashed C can be written as CP minus CP minus B dashed P. Okay. Now we can write BP is equal to image distance, which is object distance, which is minus U, CP. CP is equal to radius of curvature, which is minus R, and CP can be written as CP. CP is our radius of curvature minus R minus B dashed P. So B dashed P is our image distance, that is minus V. So we are getting minus U plus R by minus R plus V. Okay, this is what we are getting. Now friends, in triangle, In triangle APB and triangle, this is our APB, the bigger triangle APB, okay, and in triangle A dashed B dashed P dash, A dashed B dashed P, this triangle A dashed B dashed P, we can say number 1, angle ABP is equal to angle, okay, this is also 90 degree. So angle ABP, which is 90 degree, and A dashed B dashed P, which is also 90 degree. So these two angles are equal. Number 2, this angle is equal to this angle, because we know when a ray of light strikes the pole and gets reflected, then the angle formed between the incident ray and the principal axis is our angle of incidence, and the angle between the reflected ray and the principal axis is our angle of reflection. So this is our angle I, this is our angle R, but we know angle I is equal to angle R. That means we can say, okay, so actually the principal axis behaves like the normal at the point of incidence, okay. So this angle is equal to this angle. So angle APB is equal to angle BP, or we can say A dashed P B dashed. Okay, these two angles are equal. So when two angles of two given triangles are equal, then we can say the third angle will also be equal. Therefore, we can say when we see that three sets of angles are equal for two given triangles, we can say these triangles are similar. Therefore, we can say triangle APB is similar to, this is similar to sign, like, and like this is like a wave, similar to triangle A dashed B dashed P. So we know when we get two similar triangles, the ratio of corresponding sides are also equal. Therefore, we can say AB by A dashed B dashed is equal to BP by B dashed P. Okay. Now BP can be written as BP can be written as the object distance, that is minus u, and B dashed P can be written as image distance, that is minus v. So if we cancel minus, we get u by v. Now we can see that this is the value of AB by A dash B dash, and again we can say AB by A dash B dash is equal to this. So these two values, this and this, okay, we can equate these two values. So let us equate them. So let us assume this is our equation 1, and this is our equation 2. So from equation 1 and 2, by comparing the values of AB by A dashed B dashed, we get this. Okay. Now if we cross multiply, so let us take this to the left side and let us take this quantity to the right side. So we can write Ru plus Rv is equal to 2uv. Now dividing both sides of the equation by UVR, we get 1 by V plus 1 by U equal to 1 by 2 by R. Okay, so we can write this can be written as 1 by R by 2, which is equal to 1 by F, or we can write so this is our mirror formula for a concave mirror when the object when the image is a real image. So I hope you have understood it. Go through it carefully, you will be able to understand. Now friends, Let us come to the next part of it. So this is our topic now. Derivation of mirror formula. For a concave mirror when the image is a virtual image. So let us first draw it. This is our concave mirror. So let us assume an object is placed between the pole and the focus, and from this point two rays are coming out. First ray, which is parallel to the PA, after striking the mirror it passes through the focus, and the second ray, which is directed towards the center of curvature, after striking the mirror so this ray strikes the mirror and follows the same path but in backwards direction. These two rays are not parallel, so they will never meet. So when these two rays are produced backwards, we get an image like this. Sorry for this overwriting. So this is our image. So let us call our object AB and our image A dashed B dashed. So let us call this point D. So when we place our eye somewhere like this, we see a virtual object behind the mirror, which is also magnified. Now Let us write the this is our object distance, which is minus u. This is our focal length, which is minus f. This is our radius of curvature, which is minus r, and this is our image distance, which is plus v. Okay, because we are going towards the direction of light. So this is what we are getting. Now let us look at two triangles ABC. Okay, triangle ABC and triangle A dashed B dashed C. These two angles are 90 degree. And this is the common angle to both the triangles. So we can write number 1. Okay, number 2, angle C is common. So obviously the third angle will also be equal. So we can write, therefore these two triangles are similar. These two triangles are similar. So when these two triangles are similar, the ratio of corresponding sides will also be equal. So we can write, therefore AB by A dashed B dashed is equal to CB by CB dashed. Now CB can be written as CP minus BP by CB dashed can be written as CP plus CP plus PB dashed. Sorry, B dashed P. Okay, I hope this is clear to you. Now, in place of CP, we can write minus R. In place of BP, we can write minus U. Sorry, this is plus V. So we can write minus R plus U is equal to minus R plus V. Now, so this is what we are getting. This is our equation number 1. I hope you are able to understand it clearly. Now friends, let us come to the next part. In triangle, in triangle, okay, we can assume this part is linear. Okay, if we ignore the curvature, okay, we can assume that dp is a line segment. Okay, it is not a curve, as these 2 points are very close, because the concave mirror is of a small curvature, sorry, small aperture. So we can say, okay, assuming this part to be a line segment, we can say in triangle DPF and triangle A dash B dash F, angle F is common. That means we can say angle A dash F B dash is equal to angle DFP. Okay, this angle is common to both these triangles, both of these triangles. Now angle DPF is equal to angle A dash B dash P. Angle DPF is equal to angle A dash B dash. Okay, angle DPF, which is angle DPF is 90 degree. This angle is 90 degree and this angle is also 90 degree. Therefore we can say these two triangles are similar. Therefore triangle DPF, we are assuming that this part is not a curve, this is a line segment, and which is 90 degree to the principal axis, the DP part. Okay, therefore triangle DPF is similar to triangle A dash B dash F. DP by A dash B dash should be equal to FP by FB dash. FB dash. Okay, see it carefully. Now we can say dp is equal to ab. Okay, dp part is approximately equal to ab. Okay, so we can say dp is equal to ab. So in place of dp, okay, in place of dp we can write ab. Therefore we can say fp can be written as fp is actually focal length, so it can be written as minus f. A dashed b dashed, sorry, fp can be written as minus f. Now fb dashed, fb dashed, it can be written as fp plus pb dashed, which is equal to minus f by fp means minus f plus pb dashed means v. So this is what we are getting. This is our equation number 2. So we can write from equation 1 and 2 we get, we can compare these two equations because we can see this is ab by a dash b dash, this is also ab by a dash b dash. So these two things can be compared, we can equate them. Now this is what we are getting. Now let us write r in terms of f. So we can write so by cross multiplying we get this. Now 2f square and 2f square can be cancelled, or if we take this term to the right, to the left side, and if we take this term to the right side, we are getting minus fv minus uf is equal to minus uv, or dividing both sides by minus UVF, we get 1 by U plus 1 by V is equal to 1 by F. So this is our mirror formula. I hope you have understood it. In our next class, we are going to deduce the mirror formula in case of uh, convex mirror, and after that we are going to solve some numericals related to mirror formula and magnification. If you liked my video, please like, share and subscribe, and thank you for today.